Okay. Good evening. Thanks for joining us. And so today, an introductory session. Of course, as I've been explaining, and in the syllabus, these are optional, and but I think they're very helpful. And that is optional live meetings of a distance learning course. I'll introduce myself. We'll do a course overview, look at the syllabus contents there. I know everybody could read a syllabus, but going through it, and anywhere along the way, if something is not as clear as you'd like, just interject a question verbally. I'll see if I can also open the chat here, so you could do that as well. Let's see, where's my chat? Oh, okay. So this is Gen Chem 2, and hopefully you had a successful Gen Chem 1. Thank you all those that have completed that pre-class questionnaire. It's just my giving me some information about the who's making up the class. It is not a large class. We have it's moving around between 15 and 20 students. And that's fine. Hopefully everybody had a chance to look around a little bit in Blackboard, get a feel for the organization of how we'll run this distance learning course and what's the expectations. But I'll go over some of that, just enhance maybe a little bit of what you've seen in the syllabus, and see if there's some initial big questions, some issues with the textbook, or I suspect there might be some questions around this lockdown browser, excuse me. I just ate a grapefruit too quickly. And as I said, I'll tell you, introduce myself, what what I've been doing, what I'm doing at the RCBC, what else I do, and some expectations and advice. Lockdown browser. Okay. These optional online sessions, approximately every couple of weeks, but especially before the exams. That's a good place to go over some of the questions that or some of the problems that you worked out, some things that I've noted maybe in how students are approaching the problems, or where's the common kind of issues or stumbling blocks along the way. Hopefully not too many. Okay, first, let me know, can you hear me, and can you see this first slide? Someone let me know.
Yeah, I can hear you and see it.
Same here.
Yes.
What was that? I didn't hear it.
I can hear you fine.
I can
Okay,
hear, we can hear you and see you and see
Thank
the
you.
slide.
thank you. Okay. Now, so like this. All right, so let's see what we have here. Remember, just interrupt. We right now we're a very small number of people here, so it's just make it a conversation. It's a good idea. I don't know what you did in Gen 1, or maybe as you're going through it, changed a little bit, or what advice you got. So as in Gen 1, Gen Chem 2, it's practicing problems. It's working out problems. There's a certain amount of, studying to understand, to get vocabulary, to get brilliant concepts, but a big part of it is practicing the problems. Practicing the problems, especially in this second half, is conceptual, but also the process of getting to solutions very important, right? We have kinetics, we have thermochemistry, we have electrochemistry. So these are problems that will work out to get them, acid-base chemistry, and hopefully you enjoy the lab more. By understanding concepts, and we try to keep up with the lab, and the lab is made to coordinate with the pace that we go through in the lecture. Okay, so being organized is always important. Hopefully you're working out or have worked out the best organization for you, for your learning. Keeping a notebook, whatever that means to you. Your style, whether it's electronic, whether it's paper, whether it's a hardbound spiral, whatever. Real important to be consistent. And then working the problems, have a good place, a regular place that you work out the problems, kind of. And I'll explain a little bit of what I expect in you showing your mastery, or at least strong attempts at solving all these problems, and how you convey that to me. All right, you're not handing me paper, you're not handing me a notebook. I'm asking for scanned, worked out problems. Of course, not just answers to a problem, a numerical, but the process of getting there. Like you've learned a lot in Gen Chem 1, stoichiometry, and the best way to get there is to think through dimensional analysis. And dimensional analysis it's a tremendous, powerful technique, and you could use it in lots of things. We're always trying to convert from one thing to another to get to some meaning, right? It's not just moles, it's not just volume and mass, etc. Okay. Practice problems. Working skills. You do have to recall, and hopefully you mastered things, because that makes it you don't have to go back. These skills: balancing equations, writing out your process of how to solve a problem, right? It's much better writing out more, better for you and better for convincing an instructor that you gave good attempt, and showing your level of mastery. Mole conversions, these are things that are assumed. If not, then kind of quickly and review, so things don't present that kind of challenge. Making the time, not just for rushing before the due date to the assignment of the problem set, to write it out and stress out, but have a regular time. And that, and I see that everyone in this course has taken at least 2 distance learning. So if you've been successful, you had to work out some discipline of how you get through it smoothly. There are different kinds of resources. You have the text. You'll have lectures that I'll kind of take some material that's available through the textbook and highlight some of them, talk through some of the problems, try to highlight some of the most important areas to enable you to solve the problems and get the concepts. So we start out with kind of the challenging, I think is kind of challenging, and that is the kinetics chapter. Kinetics and equilibrium, in fact, the two chapters that are, I think, are pretty challenging. And then from there, I think it's a little lighter, but still pretty intense, that you have to be working out these problems. When we get to acid base, that's another kind of equilibrium, and then electrochemistry, and then some fun topics, nuclear chemistry, and thermochemistry, and a little bit of touch of organic at the end. Okay, so let's see what we have here. A little about myself. I've been kind of curious, since that's not a black and white picture of me, but when I was young, parents, and it was at the time, you could buy for kids a pretty elaborate chemistry sets, and could be dangerous, and but probably spurred my curiosity in the sciences and observation and being patient with that kind of thing, and exploring. And it's me more currently. I'm involved with American Chemical Society nationally and in the Princeton section. So very much my background is a combination of disciplines and fields, and I like integrated kind of sciences. And it was chemistry, food science and nutrition, and environmental chemistry. And my master's and PhD projects were involved a little bit of analytical chemistry, some compounds in citrus, unique to citrus, that potentially have health, biological activity. And those were sets of compounds called flavonoids. And then a PhD project related to what I ended up doing in industry for about 25 years, and that's looking at molecules that we use as crop protection, pesticides, insecticides, and herbicides, and what ultimately happens to them in the environment. You know, they're made to do a certain thing, kill a pest or kill insects or weeds or whatever, but we have to profile them, very detailed profiles of what happens to them in the environment. What happens to non-target organisms? Where do they go after they're applied? What happens to them? Do they get to water? What's their risk of non-target toxicity and that sort of thing? So that was I was an industry scientist, companies in the Central Jersey area, and then in the last 6 years, I moved out of that into education. I've been with RCBC as an adjunct, and also Mercer as an adjunct, teaching chemistry, various courses in chemistry, and also surprising nutrition. I still have a lot of interest in nutrition, and I'm currently teaching this course and a nutrition course, both distance learning course. In my daytime, I'm a teacher at a private STEM-based high school, where I teach in the Princeton area. I teach chemistry and AP environmental science. So I keep pretty busy. I really enjoy fitness. Up till this year or so, I've been running a marathon every year. I've run 21 marathons, but I'm switching over to do other things, swimming more and doing some triathlons. I did an Olympic distance triathlon this past summer in Mercer Park. That was pretty intense. Okay, so the chemistry in our body, in food, and the basis for them, that's kind of the things that we're learning in class here. And I like analogies. Chemistry is one of the things that we're chemists at least say, and lots agree, chemistry is the central science. It helps us kind of see things better, even though we have to model things a lot. We don't see individual atoms and molecules, but we have to use the scientific method, accumulate evidence, propose theories, and then maybe move to very rarely get to we absolutely know this, and those are the laws. There's very few laws, lots of theories. So when we look at something like this is water that's been put on a burner, and then for after a while, we all kind of know what's going to happen there. We see bubbles, and we, staying objective, we're not sure what those are. We might, do some thinking. We might do some experiment, but we could propose something. And so what's the initial thought when we see bubble? If someone asks you, hey, you're taking chemistry, what are those bubbles that come up from water when we call it boiling? Does everybody know that? What are the bubbles that are coming up there? Anyone take a guess? Can't be helium. It's probably not much CO2 in there to boil out that much. So we don't know for sure. We're not going to do chemical analysis on boiling water. But what's a theory? If you want to propose a theory or do something simple to convince someone of the possibility of what those bubbles are. Anybody have an idea what you do? No. Okay, so some common thoughts would be, oh, that must be because I know water is hydrogen and oxygen. Maybe it's hydrogen gas and oxygen gas coming up there. Maybe they're splitting into gas. Well, okay, which you could test that because we know that hydrogen is probably explosive, right? So maybe you can hold a match there to see if you get kind of a little ignition there. But here's another thing. What if you held your hand over that without being too close? What do you feel? What's the you feel heat, but you also feel what? You feel moisture. And that kind of gives you a clue. Maybe it's just water that became water vapor, right? So that's a proposal that actually is the answer. It's water vapor, but that's one thing you could at least start to think about and see. So it is water vapor. That's all it is. We know that water has a boiling point. Everything we have experimental evidence has a boiling point of some kind. We know that's 100 degrees C, at least at 1 atmosphere. That's where we are here. Okay, so that's seeing more as we think. So we just did kind of thinking through this. So we gotta see more. This guy over here, anybody know who this guy is? So lots of scientists look like this guy. I mean, in terms of kind of a lot of hair, beard, tired. Anybody remember who this is? You learned about him, Okay, this is a big accomplishment known for that. That's the published first kind of proposed periodic table. So that is Dmitry Mendeleev had this vision, envisioned things. They were accumulating, scientists from around the world were discovering different elements, and he saw patterns in them and put them together, and eventually, and knew his claim to fame maybe is to do this, but also said he left gaps in between. It seemed like there's a pattern there. Maybe there's an element that belongs here and here, etc. And then at the time when he was playing around with it, there was between 40 and 60 elements. We know now, we're up to, with the synthesized one, we're up to 119. So a lot of interesting stuff that we learn about and think about. And so extend that a little bit here. So everybody has seen this. This kind of logo is ubiquitous, to use a fancy word, everywhere. And I want to see if anyone knows the hidden image that's in the FedEx logo. Anybody know that? Anybody ever read about that or hear about that? So I know it from reading in a book. I didn't see it myself. But the interesting thing is that once, and this is why I like to use this and it's used as an analogy, that once you see what I'm going to point out to you, if you didn't know it, then you can't not see it again. So if you don't want to know, then close your eyes, because I'm going to show you something here that there's an arrow in that image there, right there. I'll show it to you in the next slide here. Right there is an arrow, and it is very cool because now you can't not see the arrow. So it's pretty cool. So now when you see trucks go by, you see whatever, or you get an envelope from FedEx, you see that arrow, and you can explore if you get a delivery from a FedEx gal or a guy, and say, "Wow, do you know what's in your logo?" And lots of times they don't, and it's interesting to see how they respond when they see that and they didn't know it was there before. Because I was surprised that a lot of the FedEx employees don't know it's there. So anyway, it's kind of a fun thing. I think this, and I'll just stop these things, but Tostitos is a cool little hidden image here. Then this is, again, the analogy is we learn and we're directed to things, and it's interesting. Maybe you see it already, but here in the middle here that I'm circling, there's kind of two people there, stick figures, and then we got this kind of a chip here and a bowl of salsa. How about that? So right in that image, if you're a Tostito fan, then maybe you didn't see that before. It's cool to know that that's there, and you can, make things more interesting while you're sitting around eating chips and with a beverage. Okay, so again, so it's some of the interesting things that came out of the questionnaire. One of the questions was a career path, and so I I didn't put enough choices here because the majority one was other. Okay, so I guess I should have put I don't know. If this is a chemistry, basic chemistry is what I left out there. I didn't put health professions or allied health or medical school or veterinary technology or whatever. The second one is nursing. In the other course that I teach, that I've been teaching for about 7 years, the nutrition, dental hygiene, and nursing are the predominant tracks of students. So here we have people in other assorted paths. That's great. Okay, I'm glad that everybody said they have 2 or more distance learning courses. I guess that's coming out of the pandemic. Everyone's gotten a little bit more used to, comfortable with that, and hopefully down the road we'll see that it was we made the best of it, and it took education and in a good direction. I hope it took some adapting for instructors and students, and hopefully it's a positive direction. So it wasn't truly conclusive of when to have these, when's best for everyone. It was kind of split a lot, but Thursday just happened to be a little more. I'll see if at least some people, and you guys are here, and maybe the ones that we have before exams with more students trying to show up, and I'll maybe take another poll. Is Thursday okay, or something else better if you want to be in person? Okay. And so majority said either probably or very likely. And though this maybe this first one was not everyone was excited about or making the time for. Okay. Kinetics, the first topic, very interesting stuff that we can, some of it does come off as abstract and get bogged down in this understanding and doing calculations, setting up problems, but this is very, very practical and important, an important chemical reaction that we hope will work all the time. Well, it's proven, and we have a lot of faith in it. This is the chemistry of an airbag, which is kind of an amazing how fast chemical reaction happens. This is, so we have here sodium azide, which when there's a certain collision that's sensed by an automobile, that there's a crash sensor that sets off a current that's enough to set off a mini explosion that converts sodium azide in milliseconds, tens of milliseconds, to sodium and nitrogen gas that is a precise amount to fill up that airbag. And we hope that that airbag does not have that anything that doesn't have moisture, because that would moisture would be problematic, because sodium solid is very sensitive to moisture. That would be very explosive, and you don't want that in this situation. So a precise amount, that would be stoichiometry, but the kinetics is that this is a very fortuitous reaction, and the technology was wonderful, and how it's being used now. There are some safety things that are put in here to make sure the sodium doesn't hit moisture. It's quenched with another reactant to make that inert. But pretty neat, and that is really fast kinetics. Okay, a bit going through our syllabus, just pointing out, and please ask any questions that's unclear, because that'll help me too, that if something wasn't could be expressed more clearly. Okay, it's the textbook. Everybody should, and maybe it's not made clear all the time, but you take the first half of this that but someone did ask me. Yes, it's part of the tuition that you have the electronic version. If you like hard copy. Of course, maybe you did buy the book. I'm still kind of on the fence of using electronic textbooks and paper. Anyhow, calculator, very important, as I'm sure you know from Gen Chem 1. It's very important to know your calculator and use it efficiently and effectively. Not during a quiz or test to be bogged down thinking about, wow, how do I put in a negative exponent? So no, you really should have that down, or how to do an anti-log, how to do a log. If not, there's lots of resources out there. You could just find a decent YouTube. There's YouTubes on anything. Just make sure that it sounds like it's has integrity and the person knows what he's talking about. I want to point out one thing that maybe not everybody knows about their scientific calculator. Here's a kind of very common, inexpensive scientific calculator. And this number should be familiar to you. It's Avogadro's number. Think about how do you type that into your calculator? So how do you enter Avogadro's number into your calculator? Maybe you say, I put in, well, I just do 6.02, use the multiply, I put 10, I use the caret or something similar, maybe this thing right here, and then 23. But you can do better if you don't know this and you maybe wondered, what is that double E button? Well, double E button is very valuable when you're using exponents, and in chemistry and calculations of our level here, it's very important to put in exponents. And that's what that button is for. This is the way you can use, if you know to use that button, it's write down, just type in 6.02, press this double E button. That's how it, not all calculators just have it here. Sometimes it's the second function, but if you are not using this technique and want to be a little more efficient in putting numbers into your calculator, find a double E and convince yourself that that's the same thing as this, because you don't have to then, what are you saving? You're saving times 10 and then the caret or the other thing. So that Planck's constant, you use this along the way when you did energy. Planck's constant, when we go from wavelengths to or frequency, when we go to energy, Planck's constant. So this is kind of a complicated number. Minus 30, 10 to the minus 34 joules second. And the way to put that in a faster way is just 6.63 EE, and then the plus minus change sign, whatever your calculator, lots of calculators that's different. It might be a little bit different. It might have a minus sign in parentheses or whatever. And this calculator is this guy right here, change sign that, and you get the same thing there. Okay, just a little quick tip if you didn't know that. When I say this to people, whether it's college level, there's a lot of people say, wow, that I've been using this for years, and I wish I knew that. Could have saved, maybe accumulated a decent amount of time. Okay. All right, so continuing, the syllabus. This is from the syllabus. A syllabus is good to, if we were in person, I would give you a hard copy, and it's good too, if possible, to have a hard copy and annotate on it and make it your friend and all, because there's important information in it. We instructors, if you're doing your job well, try to make these syllabi as helpful and informative and concise as possible, and helpful to students. So course outcomes, performing calculations, and in this case, here's our targets here: kinetics, equilibrium, thermodynamics, oxidation reduction, reactions, acid-base systems for the most part. And then we have theories and concepts around those, so calculations and theories around those things. And we had nuclear chemistry. So these are all really important topics that, if you think not even too far, lots of examples in the text, are maybe not when you're doing the problems, but some of them do show you the practical importance of these things, of kinetics, of equilibrium, and nuclear chemistry. You learn some of this, nuclear power. Understand a little bit about that. Why is that so unique and tremendous and have so much potential? Overall, sciences, chemistry, they improve our written oral communication when you interpret lab results, when you have to if your instructor is asking you to write observations and then make some conclusion statements, it's a test in written communication. Using scientific method is the basis for well, science understanding, innovation, and all. Okay, the topics, good to kind of think about what do you know to start with about these concepts, and try to get excited about that, page through the text and all, to get yourself ready for the next 14 weeks to get through this before the holidays. You'll be more accomplished, see more as we get through Gen Chem 2. Okay, Blackboard. If you've been at RCBC, you're probably very competent with Blackboard, but there's always help and little videos and things to that you can look at. Lockdown browser, that might be new, but I think everybody probably if really introduced. Maybe in spring. It was new to me over the summer. It's the first time I used it in a class. There's some hurdles that some students have with consistency, with making sure that this browser isn't blocked and give it access to things and that sort of thing. Of course, the bottom line is to maintain academic integrity, and it's important to have in place for distant learning courses. As you don't have to think too far that there might not be everybody that has the honesty and integrity that we would hope, and ethics and morals and all, that you're not that you don't not tempted to cheat on an exam and then try to forget about it. It's a stain that is really not worth it. So hopefully no one's sick. But the lockdown browser and respond is just a reminder that if your integrity is not strong enough, here we have a way that we're going to check, and we might, if something turns up that looks a little shady, we'll ask questions about it. I'll show you what that looks like. And well, actually, if you probably everybody watched the short video. Okay, accommodations, if that applies, then certainly let me know. that's another reason why I sent that questionnaire out to what is something you privately want to let me know for your success in the course and how I can help. Okay. Attendance is optional in this type of course, as obviously. And professional expectations, this is all our jobs. We're teaching or we're learning, and there might be an occasion that we interact among each other, that is, students among each other, maybe in an optional session where, we're to act civilly and respect one another. Usually we don't have to say this, but we just say it anyway. If there's a time that I just put out a discussion point around something, and asks students to maybe comment on someone else's post, then, and this goes for any classes, you do that respectfully. And it's nice to have some interaction even in a distance learning course. So that's what that section's about. Evaluation and assessment. This is probably exactly similar, because in the chemistry, we go by this. I follow the program coordinator, and this is how, well, consistency, that's how we set up. So for exams, each equal, and then other assignments, 16%. So 21% for each of the exams, and the assignments, and then the grading scheme there. So this is the same as in Chem, Gen Chem 1, exactly the same kind of thing. There's not a makeup for exams. If there's an issue, communication is important, to let me know if something, and to know that I'm open to hear what the issues are, but I shouldn't have to ask that, show me, convince me, whatever that is, that there's justification for whatever, taking an exam early or an exam a day late or something. So documentation of whatever's going on. Assignments, they there's a deadline on assignments. They're expected to be in there, and again, an explanation is necessary to be accepted late. Here's very important, the schedule of where we are. So you should be digging in, and those sections in chapter 14, just the first two, and don't let it build up. So, concentrate, and these kind of things. Reading a textbook is, I think I put these few brochures in the additional readings, that some tips on how to make the best of your time reading a textbook. It's not like reading a newspaper or magazine or a novel or something. You really have to be focused and know your style of absorbing material that is often complex. It's not just reading through, it's studying and looking at the tables and figures and calculations, and maybe taking notes or whatever is effective for you, to not waste your time by reading it and then walking away and not remembering a single thing that you just read, just a bunch of technical terms. Don't let that happen. Okay, so look at that. There's those sections. And then there's a good amount of material there, and a lot of practice problems.
Excuse me.
Yes, go ahead.
If we have any issues with any of the homework and like any difficulties doing any of the problems, can we just email and ask questions if there's something we're confused about? Are you available
Yeah,
for
sure.
homework?
Yeah, absolutely.
Thank you.
And also at times, and that helps me too, the feedback of questions. And thanks for mentioning that. Because the feedback helps me to maybe I should make sure that either in the recorded lecture or a supplement to the recorded lecture that I stress that point a little bit. I kind of know, um, areas that are more confusing or harder to get, and I'll try to spend more time on them with similar example problems in a recorded lecture. So I also, so the things that are posted already, obviously they're not things that I made, they're from Macmill, from the publisher, Cengage rather, and no, McGraw-Hill. That those are good little short little videos to watch. It's a starting point to see that the guy writing on a board and explain good explanations. But we really have to practice, because we're never going to see exactly the question that's going to be on an exam. They'll be very similar, but so we need to know how to work them without relying on looking at the video again, or looking at the textbook, or looking at how we solved a similar problem. Okay, so yeah, we dive right into not easy stuff to understand. Reaction rates, reaction rate expressions, all these kinds of things. You got to spend time thinking about them, taking notes, and then do those problems. So each week there's something like 10 or 15 problems. Some of them are a lot of them are quantitative, some more difficult than others. Some are just kind of qualitative to make sure that, hey, this is an important concept to know how to distinguish if you get a multiple choice question, what's the best kind of answer. And in the recorded video, recorded session, I'll have some of the multiple choice questions that maybe we would use in a clicker situation, but they're good to stimulate and make sure we're getting the important concepts. Okay, so kinetics and then equilibrium. So these are two topics that are not, not easy. It takes, as I'm saying, working out problems. So sample sets, problem sets, they are on this as the A1, A2, A3, A4. Those are the things that are add up to 16%, so they're 4% of the grade. And yeah, I just want to see good effort getting most things right, and most of the time, if you've done that and sincerely worked through the problems and not try to take shortcuts and not show the process things, if you've made the diligent effort, asked questions along the way, then you get those, you get those points. It's mainly practice to do very well on the exam. Okay. So topics, dates, sections. So very detailed, that you'll be able to, say, Okay. Let's see, I'm over here already. It's October 24th. I got these 3 sections. If I'm staying on schedule and not going ahead. Let's see if so I feel like I've mastered them. Do I need to put a few more hours in to make sure that I get the problems? There's also a good idea not to wait to the end to do all those problems. The problems that are there relate to all these sections. So so as you're reading through sections and studying and all, try to knock out those problems that you've just read the section on. It's pretty clear in the back in the question area of what section all these problems refer to, and what and shouldn't limit yourself to necessarily, although it's a good amount of problems to work out, but you can work out ones that the answers are there in the back of the book.
1 second, again, sorry. On your syllabus, it says for assignment 1, A1, it says end of chapter 14 problems, and you have 5, 7, 15, 17, 19, and you list them, but I'm in the chapter right now, and it doesn't really go that way. It's, like 14.9, 14.10, 14.11, and it kind of goes more like that. So are we just assuming that there's the 14 point in front of that, like 14.5, 14.7
Oh, in the questions.
at the end of the chapter?
Yes, yeah, all have 14. You mean in the
Right. When you say 5, 7, 9, whatever, it's actually 14.5, 14.7. Those are the ones.
yeah, thanks for
No worries. I just wanted to make sure that
Yeah.
I wasn't, that
So
I was.
you're referring to, and I come to that too, the weekly assignment that when I kind of shortcut and did write down 14 for each of those numbers. Okay.
Yeah, because when I look at the next assignment, it actually does say it in front. So I thought maybe I was,
Oh,
on the wrong
okay.
page. So I wanted to,
All right.
I just wanted to double check.
Oh no,
Don't
that's
mean
good.
to be a pain in the neck, but I got, I wanted to make
No,
sure.
thank you, Kara. That's good feedback. That's inconsistent on my part.
No worries. As long as I could ask, it's not a problem. Thank you.
Okay, so lots of interesting topics here. You may have saw a little bit of them through Gen Chem 1, maybe touched upon some things, but a lot of this is, and certainly the depth of going into this you haven't seen in the first the Gen Chem 1. Okay, hopefully the examples and what you read show at least some of the application of a lot of these things. Certainly the area of electrochemistry, batteries are a frontier that's very important now. Different types of batteries are really important as we strive to find alternative energy sources, and the leading ones, we need to have good ways to store the energy that comes from these sources, from wind and solar and hydroelectric, that we always, because we don't always have, it's not necessarily a consistent source of energy, so we need to store so much of that potential. Okay, so for exams, and these are nice, worked out, and I may have changed a word or two here, but this is mostly just from Professor Stewart. So there's more of this. So each chapter has nice objectives that are set out, and you could see some of these even in the textbook. Maybe not exactly word for word, but these are the important things. Also note that not necessarily every section, only the sections that are listed there, you're responsible for. So there's some sections that, just because of time, that we're not going to cover. So these are the objectives. It's not every single thing that you could find in those chapters. And I don't have all of them. You have them in the syllabus here. There's the other chapters that I don't have in this PowerPoint here. Okay, skipping to the resources that you have. It's important to know some of these details that sometimes don't pay attention to in syllabi. But if if something happens during the semester that something that this is not allowing you to finish it, so that okay, what's the options? Says withdraw or incomplete. So here are the options that you can begin a discussion or to think about if something like that comes up. The it says there in the middle there, withdraw deadline for this semester is November 1 with 100%. Oh, no, that you can withdraw that, but for 100% refund, it's right away, September 6th. So that's so to get a full refund, that's right after Labor Day. So that means pretty quick decision that this was a mistake. Okay. Lots of support that you have as students. You just have to know to define it and know where to find support, whether that's shown here. We have Office of Student Support and Disability Services. Some of the contact numbers there, and some of the other ones with at least an initial place in the RCBC web page to find these things. Didn't mention, but you may know there is available some, well, certainly a computer lab if something happens to your computer that you've been using and you need a fill-in, don't have access to one for a day or two or so. Tech building, I think it's room 100 or 102. There's a right there near the STEM office is you got to check the hours. There's also the testing office that if you need to go there because your computer just went out and you get nervous because we're in the test window, I need to go to campus and find time to take the test on campus on the computer. Okay. There's also some let's see, where is it? Said somewhere in here there's tutoring here, tutoring center. So I don't know a whole lot about that, who does the tutoring or what, but there's that. Okay, tutoring center. I don't know if anybody ever took advantage of that. Awful lot of resources out there to help. Sometimes I post in we'll get that too in a minute. Here's our Blackboard. Just here's your textbook here, problem assignments. So I try to always, when I put an announcement here, to check the box that sends you an email that an announcement is posted. And I hope that everybody kind of sees that. And if, to remember, usually it's relevant that you should take note of. Let's see, then there's exam access and etc. So big things, problem set assignments. So let's see. The latest announcements I was trying to make clear of this lockdown browser respondus. I have a few slides here. And so if there's questions around that, you can ask that now. Okay, access to your textbook, extremely important. And you should maybe have a style of what you do with the textbook. Do you use the whatever you have here, the bookmarks? What other kind of tools do you use? Do you read through? Do you take notes? What do you do? Do you have a hard copy also to use? So really important to be consulting your textbook often. And yes, so if I should have been putting the full number there, but yes, we have chapter 14 and then the number for the practice problems. And here's our assignment and due date. So you can go back and forth to your syllabus. Tells you what week we're in and problem set number, and there I'll see that I'm organizing this enough that you get indication that the next problem set is there. But you should expect a problem set there every week that covers the sections that are for that week. This is a previous one. Obviously, this is not the exact current one because this is from the summer. I thought I took a live one. Okay, now as far as what you show when you write, when you're doing the problem sets, it's important for you to work through problems. It's just an example of how you should make your work clear and show the process. So this is just kind of, this is thermodynamics and some stoichiometry there. But an example of, showing work. When we show work, we give, and it's a good thinking process, a good practice. So how you don't have to write out the whole question, but if there's an equation that's important to you to work through, take the time to write it out. It's not worth kind of saving paper, and certainly writing out this number and expecting that looks like you put the work in. It's not convincing to me. I want to see that you did some work. If the number is off, if you've messed up with not having a conversion factor, that's okay. I want to see the whole effort, how you got there. And hopefully you see the beauty and the importance of dimensional analysis and setting up things, canceling units and that sort of thing, and writing out units and identity of stuff. A bare number is not good in science. It needs to be identified as, what is it and what's the unit? What's the unit and what it is, rather. That's the right order. And so it's in the syllabus, but I don't like 5 or 6 or more pictures. That's not what you should be posting. Find a way. There's lots of ways to do a scan of your pages. I suggested one, and that's this free downloadable app for your phone called Genius Scan. Very user-friendly. It finds what you're trying to take. It does the best of fitting on the and then if it's set right, it takes itself, or you could force it to take it, and you can crop or change, make it more legible or whatever. It has some editing features, and then you could do that in batch. Take multiple pages, and then you send it to yourself, and it goes as a PDF of a nice scan PDF of your work, and that's what you should be submitting at the assignment. And if I might have I might have even a short video that, but I don't know if it's necessary. But if there's questions about that, please just let me know. There's other, I guess there's some other. This was the simplest thing. I've been using it for years, for even for very large documents. And I don't, it doesn't take up, and it creates a really nice PDF. And it's, it doesn't take a lot of space on a phone either. So then you could delete them too. It's worth exploring. It's just called Genius Scan. Okay, lockdown browser. Just to say a bit about that. Faculty, we are, and I agree, we're encouraged to use this for distance classes. Yes, we try to make exams so that you can't be tempted to just Google an answer, right? We're not going to make exams like that, but still, this is an additional showing that we care about integrity of our classes and our college. Lockdown browser, there's a recording that's posted. You could watch too, a little more detail of a I guess that was a discussion section I did over the summer talking about the lockdown browser. And as I said earlier, there's actually two here, and there's also with Respondus, there's a video also to watch. But still, there has been possible, even the first time I downloaded it, I didn't realize that why it wasn't that simple. I needed to give on my Mac, permission to use the camera and the microphone to, that security thing in your security settings. So here's the explanation. You do need to read through, and a couple of links. One is to watch a short video. The other is to do the download. Now, of course, the download, well, that's when it's downloaded, it looks like that. If this is on a Mac and it's on the dock, it might look different on a PC. But somewhere it's there, or you could put it on your dock. And here's the install. So the install, it has to be, it's specific for our college, right? So it can't be just Google Respondus, and I'll put this, it's not like just downloading Chrome or any other browser. This is specific for RCBC. Why? Because when you open up that browser, it goes just to Blackboard. Well, here's the downloading, and then gets confirmed that and then you open up the install, and that's what it winds up. It's a repeat. Now, when you open up the browser, it tells you, okay, you have things open that need to be shut down if you want to continue using this browser, because that's the point of the browser, to have nothing else that is open and no possibility of opening up another tab, so that you're only going to log in to Blackboard. Not only that, but to our, and then you open up our course, which the chemistry list is listing my things. So you open up the course and you get here, and then you're going to be directed to the exam. Now, that's why we had this practice quiz, which this is not that it's posted. I posted it as an announcement that if you have the lockdown browser now, you can do the practice quiz. Click on this link, or it's in, this is when it opens up, or it's in the Blackboard orientation. Going through, it's the last little topic in the Blackboard orientation, and it says lockdown browser, practice quiz. And when, this is what it looks like when you open it, and then it gives some explanation. So that's why we do the quiz, so you have a time to look at this stuff. It's going to be the same each time. And then you do this thing that it's going to take a picture, and it goes through these things. Show ID. You're instructed to show the environment, although sometimes it's hard to move which you're supposed to do something like this to show me that you don't have like notes all over the place, right? But the real feature is, and this is like artificial intelligence. It watches you that you're in camera and you're not like obsessively looking around all over the place, which it sets off a little bit of a flag. Still a facial check. Okay, and after you go through that, then you begin the exam. At the end, you're asked to comment about this. Did it go okay, or was there some kind of issue? Or if you did have to run to an emergency or something, you give an explanation. I had to, whatever it is that needed your attention. Hopefully that's not because you're supposed to have a time that you don't expect to be interrupted. That's what we want. But if something happens, you give an explanation here. And then you get a confirmation that your test or quiz is submitted. This is, sorry, this is, I get a report after the quiz or test. This is just partial. There's only 7 that completed it in this, right at this point. But then I get, the software tells me that there's, if there's a priority that you should look at the video, you might want to look at the medium or low priority. That's saying that maybe the student was off camera for, in this case, maybe a few seconds or a minute or something. High priority would mean you should check because there were certain abnormalities that you might want to question, and that sort of thing. Okay, so I trust that everyone that has a problem with whatever, having that browser working and getting through the quiz, I'll see that, and I'll reach out if people in the next couple of days haven't completed the quiz, ask, was there a problem with that? Okay. So this is the material that we want to start concentrating on. I'll post in the next couple of days a video, a recording to go over this highlights of this material, but you should be diving into the those sections in the text and starting to do those practice problems. So a lot to go over here, or as a reaction, rate of reactions, as I said, all kinds of things. So hopefully it's you'll find this semester fun and challenging.